Hey, it's the distributive property. Let's get this down in your notes. We're going to be applying the properties of operations to make equivalent expressions. So by the end of this, you should be able to say, I can write an equivalent expression using the distributive property.
I think you should be able to say it in Mr. Romanovich's voice. So you
Yes.
need to practice your Mr. Romanovich awesome
That's
voice.
all I need.
That would be awesome if everybody comes in the next day talking like you. That would be fantastic. All right. First thing we need to get down is some basic definitions. The distributive property is a combination of both multiplication and addition. The way we use it is right here. We're going to multiply the number on the outside of the parentheses times each of the numbers on the inside, and then we're going to add the pieces together if we can, and we're going to talk about that part when we get there. So jot down these two examples, and we want you to kind of follow along and write them out with us. You'll notice my really dorky rainbow backgrounds here. It's for a reason. We call the distributive property the rainbow method, because what we're going to do is we're going to take the number on the outside times each of the pieces on the inside. Now, I know we know how to go ahead and do 20 plus 8 is 28 and then multiply by 4, but I want to see, can we use the distributive property to get the same answer? So we're going to kind of do it both ways. So we take 4 times the 20. Remember, the parentheses mean multiplication, plus 4 times the 8. And we draw those two rainbows to remind us that the 4 gets multiplied times both pieces. It's very easy to multiply times the first one and then totally forget about it on the second piece. Now we do our order of operations. 4 times 20 is 80. 4 times 8 is 28. And I get 32. Thank goodness Mr. Romanovich is here. And he's even polite and didn't call me an idiot for getting that one wrong. He just nudged me so I could fix it. So it's 112, right?
Yes.
All right. Now, let's pretend we had done this one as a regular problem. 4 times 20 plus 8. Let's show you that the distributive property really does give you the same answer. So order of operations, 20 plus 8 is 28, times my 4. So 4 times 28. I'll do it over here just to make sure I did it right this time. 4 times 8 is 32. 4 times 2 is 8, plus 3 is 112. So we do get the same answer. This is just another method to get there, and it's going to make a lot more sense as we tackle the next couple of problems. So I'll let you take the next one.
So we'll start with our rainbows, so we remember where we're going to. So we're going to have 5 times 3x and 5 times 7. So when we rewrite it, it'll be 5, then parentheses 3x, close parentheses, then we're going to add that to 5 parentheses 7. And we know that those, when they're abutted together, as we talked about, means that they are being multiplied. So 5 times 3x, we're just going to multiply the two numbers that we have there, the constant and the coefficient, to get 15x. Plus 5 times 7 is 35. Then at this point, can we put those together? Technically, no, because one of them's a variable term and one of them is a constant, so they're not like terms. So our answer ends up being just 15x plus 35.
All right, so let's see a couple more in action. We want to do 8 times the quantity x plus 3. And this is why we have the distributive property. We can't go ahead and do x plus 3. We can't add those because they're not like terms, but we still want to be able to multiply by our 8. So we're going to use the distributive property. First, I'm going to write in my 1 in front of my x, like always, and then our rainbows. 8 times 1x and 8 times 3. Yes, you have to write out this next step so we can see what was being multiplied together. So we want to see the 8 times the 1x plus the 8 times the 3, and then you go ahead and you do the math. 8 times 1x is 8x. Remember, just multiply the number parts, the variable tags along. 8 times 3 is 24. And then stop and ask yourself, can I add those two pieces together? In this case, no. One of them has an x, one of them doesn't, so they're not like terms. So 8x plus 24 is our answer.
Then the second example, we'll put in our rainbows again, 5 times 9 and then 5 times 2y. And then we rewrite it, it'll be 5 parentheses 9 plus 5 parentheses 2y. That's when we start doing the multiplication. The biggest mistake people make in 7th grade is they forget to do that second term. By writing it out like this, you're going to remember to do the second term. So 5 times 9 is 45. And then 5 times 2y is just 5 times 2, and then tag on the y, 10y.
And again, they're not like terms, so we're going to stop right there with it. Now let's put it into action. It says 3 friends are going to a concert at the fair. They each want admission to the fair, which is $6, and a ticket admission to the concert, which is $22. We want to write 2 different expressions, 2 different ways of finding the total for the 3 friends. So I'll take one way. There's 3 people going, so they could do 3 times the ticket price of $6, and then 3 times the cost of the concert tickets. So it's basically buying 3 admissions plus 3 concert tickets. We could do the math and get to our answer. 3 times 6 is 18. 3 times 22 is 66. 18 plus 66 would give me 94. Did I do it right this time? What did I do wrong this time?
It's 84.
84? You're right.
You're doing that on purpose now, just to see if I'm paying attention.
I wish I was. I wasn't. All right, Mr. Romanovich is going to show us a second way of finding that exact same answer.
I think the way I would do it is I figure out how much it would cost for one person to go. So one person, it would cost $6, and it's going to cost them an additional $22. But we need to find for 3 people. So let's make that a quantity and multiply the whole thing by 3. So then, how would we do this? Are we going to do inside the parentheses first as the demonstration here? So we'd have 3 times 28.
Yeah.
Yeah, so we're going to add our 6 and 22, just to be sure. And we have 28, and then we're going to multiply that by 3, and that gives us 84.
Assuming I did it right. I'm hoping so.
Yeah, carry the 2.
All right, so you can see that had we just gone ahead and done inside the parentheses and then multiply times 3, gives us the same answer as multiplying each piece by 3 and then adding those 2 costs together. So it's just a way of showing 2 different ways of getting to that same problem. So let's do the same thing again. Each day, Martin lifts weights for 10 minutes. It's a very quick workout. And then runs on the treadmill for 25 minutes. We want to write 2 equivalent expressions, so 2 different ways of getting the exact same answer if he exercises that way for 7 days. So I'll take one way. He exercises 7 times, lifting weights, 10 minutes each time, so 7 times 10. And then for 7 days, he also runs on the treadmill for 25 minutes. So I can find out how much time did he spend lifting weights, plus how much time did he spend on the treadmill. 7 times 10 is 70. 7 times 25 is 175. Did I do that right this time? All right. I really have to check this time.
Now I have to go.
70 plus 175 is 245 minutes that he spent working out that week.
Good job, Martin. All right, and then the second time we would do this, we could do this as a quantity. So for one day, he's doing 10 minutes and 25 minutes, so 10 plus 25. We put that in our parentheses to know that they're grouped together. And he's doing that for 7 days. So what we do is solve inside the parentheses first, and we'd have 7 times 35. And then that works out to 245. 7 times 30 is 210, plus 35 is 245.
So you're showing one way where you're multiplying each piece by the 7, and then one piece where you're doing your addition part first, and then doing your multiplication. Either way, we still get the exact same answer. That's why they are equivalent expressions, because they're equal to each other. Have a good day.
Good luck.